If the series from n equals 1 to infinity of a of n converges and a of n is just like a coefficient. And so a0 is probably the first one, a1 is the second one? Because 0 probably, not important. Not important. I guess a1 would be the first one. Okay, focus. Converges and a of n is greater than 0 for all n. Okay, so which of the following must be true? Okay, so first thing you notice is an greater than 0 for all n. And this is basically saying no alternating series tests. So don't have to worry about alternating series tests. Alternating series test is you have some sort of something, it alternates, but it goes to 0 eventually. And you also have something that alternates like -1 to the n. Okay, so this is basically just asking about all these various tests. So which of the following must be true? Okay. Absolute value of an not necessarily true. So first one, whoop, here we go, click clack, clickety clack. So look at this, we have a graph, it goes like this. I'll say it looks like this. And this could be the value of 1, and all the values are less than it, and it could converge, and that could be true. But you could just double this. Let's say with 1, it converges to like, I don't know, 10, a value. So convergence just means not infinity. Well, if we double it, we just multiply everything by 2, then it would converge to 20, because you'd have twice the amount of, what did it converge? Yeah, it converged to 20. It'd have twice the area underneath the curve. So it can converge, and it has nothing to do with each individual value of an, the coefficient, doesn't have to be less than 1. So that is not, which of the following must be true. So nope, that one's not necessarily true. Limit of a to the n plus 1 over a to the n goes to 0. This is talking about the ratio test. I don't usually talk too much about the ratio test, but the idea here is if you take the limit of a to the n plus 1 over a to the n absolute value, and that ratio is less than 1, then it'll converge. If it equals 1, then you don't know, and if it's greater than 1, then it diverges. So it has nothing to do with 0. Nope, that doesn't even make sense. So, but if you looked at that and you're kind of familiar with the ratio test, you'd be like, oh, converges, ratio test. You might not realize that, oh, that's 0, completely meaningless. It'd be more meaningful if it equals 1. But it still wouldn't be. No, because now if it said less than 1 or less than or equal to 1, then that would probably be true. It would be true. Okay. A to the n of the n diverges? Not necessarily. So if you had 1 over n squared, and then you had n times n over squared, then that'd be 1 over n. So you'd be like, oh, this one converges, but that one diverges because it's a harmonic series. That would be true, but that's just one example. The coefficient of an could be something along the lines of 1 over n cubed. So then when you do n over n cubed, you get 1 over n squared, which still converges. So not necessarily true. So messy. So messy. What disorder? A to the n over n converges. Yes. So this one will be true. So the reason this one is true is because you can do it by the comparison test, And so you have, I'm going to draw, this is the series with coefficient a of n, and then n is just a positive number, 1 or higher. And so a to the n, or a of n, an over n, this series divided by n, will be smaller than the series of just an. And so if this converges and something smaller converges, then the thing that's smaller has to converge as well. In this last one, think here they're trying to say that a to the n equals 0. And so, okay. So I think what they're saying here is you have a graph like this, and it's trying to confuse you about the last term and the summation of the terms. So the summation will not equal 0. Just because a series converges, it does not equal 0. It converges to, like, it can be a number. That number can be 0. But it can also be like 2 or 10 or anything less than infinity. Or greater than negative infinity. But the last term will have to be 0. Because if the series doesn't eventually work its way towards 0, then it'll keep adding numbers. And so the last term has to be 0. But the summation of all the terms between the first and the last will not necessarily be 0. And it kind of feels unlikely. So the only one of these statements which is true is a to the n over n. This is kind of a cool question because it really kind of works through a lot of the different convergence divergence tests. And kind of throws out easy human performance traps, easy things to get wrong. And it really kind of tests your knowledge on, hey, why are these convergence tests true? When are they true? And what are some of the exceptions? So that is how I would go through this problem.